Hello. So this week we will be working on Lab 7, Conservation of Energy for our Physics 207 lab. So if you open the Blackboard page, you should have access to the simulator over here, right? So here there are so many options over here. So I'll go over with you the options that we are available on the simulator. So all the possible actions that we can do. So here, if you want to change the scalar, like choose scalar. So here I like to use the PET scalar, which is 75 kilograms, but just in case if you want to use a bowler, you may do that. So pick and say okay. So when you're working on the last application question on the lab manual, you might need to use a ball. So pick the ball and say okay. So you can change the character on the simulator. Then by using the grid, you can get an idea about the position of this track, right? Also, you can move this track to wherever you want, okay? And also you can zoom in and out. See, like, so you can zoom in, so you can make the grid lines showing more area in here. So if you want to extend the track, you may do that as well, right? So you can move the track, or you can change the shape of the track, or whatever you like to do with the scale. So basically you can design your roller coaster, right? And also you can take the potential energy references. So here, this level, like if I am assuming that the ground is my zero potential level, I can keep it on the ground. Or if I want to decide some other place, I can move it and make that place the zero potential level, right? So this is the zero potential level indicator. Then when I want to analyze it, let's say I want to place the position. So I'm doing this experiment on Earth, so I pick Earth. But if I want to go to Moon, I will change that. So the gravitational acceleration over here will change. So Jupiter, you know, on Jupiter, the gravitational acceleration is higher than that on Earth, space. So gravity will be zero, right? So depending on where you want to run the experiment, you need to need to pick the correct location. Then also you can add friction. So if you click the track friction, you can change the friction on the track. So in the first part of the experiment, you don't need any friction. So let's keep it as none. And also you can take the variation measurement. So you can click on the energy versus position. And also you can take energy versus time graph. And you can move this a little bit so you can see your skater and the track, right? Arrange it nicely in a way that you can see it. Then let's say return the skater, and then I have to pick the skater and keep it somewhere that I like to move him. So you can move the person to wherever you want him to start. So let's say I want to start it from this position. So I start it from here. And I think you all know how to read the grid. So here, this is the y-axis that's starting from 0 and go all the way to 12. So depending on where did you zoom it, and x-axis is along this way. So if you want to read a position, you have to read it accordingly. So if you keep the position over here, that means the x value is, let's count, 1, 2, 3, 4, 5. And the y value will be 2, right? So this position will be 1, 2, 3, 4, 5, 5, 2, right? So likewise, you can follow the lab manual and make your track, right? So on this one, on the energy versus time graph, you can see the variation of kinetic energy, potential energy, and also the thermal energy and the total energy. So if you want to recollect the data, you have to clear your data and then start tracking it. So say go. So it will track the variation. Now let's say I want to change the potential level, I can change it. So it will change the graph a little bit as well. So you have to understand why it is changing, right? And also on this one, you can see the variation of energy with respect to the position. Okay, so there are so many options that you can use. And also, let's say you make it a mess and you want to reset it, just hit the reset button. So you can reset the scalar again. All right, so I hope this will help you to complete the lab manual. And when you're working on the application questions, you may watch the video that I attached, helping you to work on those problems. And in the last question, it's asking you to try your calculation. So in that case, you may develop the new skate track. So basically you need to have a loop-the-loop apparatus. So if you were in the lab, really there was a loop-the-loop apparatus that you can try a simulation, right? So anyway, so using the track pieces, you may develop your track. So make it a loop-the-loop apparatus skateboard, like skate track like this one, and then try the motion of the ball, right? So if you want to keep it like 2 times R, you have to measure the R and start the ball from that height. Okay. It's hard to catch this ball. Let's catch it. Yes, I know. Anyway, so I already started, so that's why it's hard to catch, but you will try resetting it, and maybe I can pause it, then I can catch that, right? All right, so here's the ball. Then let's play it. So I'm going to take it and keep it like, let's say this is the diameter of the track is about 1, 2, 3, 4 grid squares. So I need to keep, let's say in R distance, 2R this height. So from the ground to R height, I keep the ball and I let it go. So the ball cannot make it. So there's no enough energy for the ball to complete the loop, right? So let's say in your calculations, you got 2 times R, then keep it there. 3 times R, then keep it in that height and try it. Right? So likewise, you may try your calculation using this simulator. All right, so thank you. And if you have questions, please join us in the Zoom meetings, or you may email the TAs or me. See you in the next week.